Hey everyone, welcome to Chemistry 1 Average Atomic Mass, where in this video we're going to go over practice problems, and these are a little bit more complicated. Last video we talked about finding the average atomic mass when we have everything that is given to us. But in this situation, we have a situation where everything's not given to us, and so we kind of have to work backwards. So in this problem, we have lithium ions that are naturally occurring. That's important. That means no radioisotopes are involved in the question, and they will never be involved in this question because they have to be naturally occurring. And they in this question, they actually give us the atomic mass. So it's already found. But they give us the two isotopes, but we don't know the abundance here and we don't know the abundance here. So it's kind of working backwards. We're going to start with the weight that they gave me, which is 6.941 AMU. And then we're going to do the setup that we do normally to get this. So it would be a percentage here. We don't know what it is. I'm going to put X here. And then for the other one, because I know it has to be that the isotopes sum up to 100%. If I have an X percentage here, I know the other one has to be 1 minus X because they have to equal a certain percentage to equal 100%. So now I'm going to plug everything in, and I'm going to do X times 6.0151 AMU, and then 1 minus X times 7.0160 AMU. And then I'm going to do the math. I'm just going to bring this down, 6.941. I'm going to leave AMU out for the moment for space purposes, but I suggest you write it all out. Now, let's do the math. This becomes 6.0151x. And then here I'm going to distribute. Both of them have to be multiplied by 7.01. So 1 times 7.01 is going to be plus 7.0160. And then minus 7.0160x. Now, I'm going to look for things that I can combine. This has an X term. This has an X term. I'm going to combine the two. That's going to be equal to bring everything down, negative 1.0009x. And then I'm just going to bring everything else down that wasn't combined. Now, I need to isolate my variable. So I'm going to, if I have a plus 7, I'm going to minus the 7.0160, and I'm going to do the same thing on this side. That cancels out. The math is going to be negative 0.075. So you could say negative 1.0009x. To isolate the variable some more, it's being multiplied by x. I'm going to divide it by, multiply by negative 1. I'm going to divide it by negative 1. Canceled. And then the math is 0.749. That is equal to x over here. Now, and then I'm going to do, so therefore, this one is 1 minus 0.749, which is equal to 0.925. Now I have my percentages because 0.749 is and let me correct this, guys. I apologize. This is, fix this here too. It's 0.0749. That is equal to 7.5%. And this is 92.5%. So this first isotope is found 7.5% of the time, and the second one is found 92.5% of the time. So if we want to check our answer, 6.94 should be in between both of these, and it is. And then the actual weight should be closer to the one that's has highest percentage naturally. 6.94 is closer to 7.01, and that makes sense because this is found in the earth 92.5%. Let's do this one more time to kind of solidify this in our brains. This time we have rubidium that we don't know the percentage, but we know the mass. Same thing. Their other isotope, we don't know the percentage, we know the mass, and we have the average atomic mass right here. So we're going to start with 85.47 AMU is equal to, I'm going to do the same thing. I do not know what they are, but I know that since they're naturally occurring, keyword, that in my problem, all the isotopes that they give me have to equal to 100%. Right now it's 2. If it was 3, it still have to equal to 100%. But you're rarely going to find questions where it's 3. It's going to be 2. So you can do the algebra. So I'm going to make this x, and I make this 1 minus x, because even though we don't know what they are arbitrarily, whatever this is going to be 1 minus whatever that is. So they both equal 100%. Alrighty, so let's do the math. We have x times 84.912 AMU plus 1 minus x times 86.909 AMU. Bring this down. We're going to do the math. This is going to be 84.912x. I'm not going to do the AMUs right now for space purposes. And then for the other part, we're going to distribute this 1 and this x. So it's going to be plus 86,909 minus 86,909x. Look to see if I can simplify. This x and this x can be combined. So we're going to do that. That's going to be negative 1.99x. That's been canceled out. I'm going to bring down the 86.909. And then I'm going to bring this down to 0.47. To isolate this, I'm going to subtract this because it's being added. And I'm going to subtract it on both sides. So minus 86.909 minus 86.909. I get negative 1.439. 1.997x is brought down. This is being multiplied by negative 1. I'm going to divide it by negative 1.997 to isolate it. X. And my answer is 0.721. And this is also the same thing as saying it's 72.1%. So that's what x is. And then to find the other value, which is 1 minus x, 1 minus 0.721 is equal to 0.279, or 27.9%. Both these percentages, 72.1, 27.9, equal 100. So I'll put here 27.9%. That looks so bad. 27.9%. And then this one is 72.1%. Hope this was helpful, y'all. If you have any questions, let me know in the comments.